Hello, my name is Cherry, and I would like to answer the two questions about the week 3. I'd like to describe how I would write a function to find the intersection of two sets without using the built-in method. My approach is to iterate through the smaller of the two sets and for each element efficiently check if it also exists in the larger set. The most efficient way to perform this check is by using and hashed as a lookup table, which provides constant time access on average. This is the process. First, the function would accept two collections. Let's call them set A and set B. To optimize, I would identify which set is larger and which is smaller. I then create a hashed from the elements of the larger set. This hashed will be our lookup table. Next, I would create an empty list or set to store the results of the intersection. Then, I would iterate through each element in the smaller set. For each element, I check if it contains in the hashed we created in step 2. If it does exist, I'd add the element to my results list. After the loop completes, the function would return the list of intersecting elements. Talking about the big O performance, the time complexity, this approach is very efficient. If the sets have sizes n and m, the complexity is O n plus m. This is because creating the hashed takes O(m) time assuming m is the larger set, and iterating through the smaller set takes O(n) time. Regarding the space complexity would be O(m) for the space required to store the hashed of the larger set. To ensure my function is robust, I would use at least 3 test cases. A standard overlap, I would set A is going to be like one object of 3 elements, the 1, 2, and 3, and set B is going to be another object of 3 numbers, 2, 3, and 4. The expected result is 2 and 3. It's an object of 2 elements, number 2 and number 3. This validates the basic logic. To overlap is another test. I would set A equals to an object of 1, 2, and 3, 3 elements, and set B going to be another object of 3 numbers, 4, 5, and 6. The expected result is an empty set. This handles the case where there's no intersection. Set is a subset. That's another case to test. I would put set A going to be an object of 2 elements, 1 and 2, and set B going to be another object of 4 numbers, 1, 2, 3, and 4. The expected result is 1 and 2. That's going to be the result. This ensures the logic works correctly when one set is fully contained within the other. This approach is both efficient and reliable for finding the intersection of two sets. Now I'll describe how I would write a function to find the union of two sets, again without using the built-in method. My strategy is to leverage the properties of a hash set to automatically handle uniqueness. I would start by adding all elements from the first set into a result hash set, and then iterate through the second set, adding its elements. The hash set will ensure no duplicates are stored. The process would be something like this. The function would take two collections, set A and set B, as input. I would initialize a new hash set and populate it directly with all the elements from set A. This is a very efficient starting point. Next, I would iterate through every element in set B. For each element from set B, I would simply call the add method to add it to my result hashed. The hashed itself handles the logic. If the element is already present, it is simply ignored, otherwise it's added. After the loop has processed all elements from set B, the result hashed will contain the complete union. Finally, the function will return this hash set. Talking about the big O performance, time complexity, this approach is also very performant, with a time complexity of O(n) plus m, where n and m are the sizes of the two sets. It takes O(n) to initialize the set with the first collection, and O(m) to iterate through and add elements from the second. About space complexity, in the worst case scenario where there is no overlap between the sets, the result hashed will store n plus m elements. Therefore, the space complexity is O(n) plus m. My test cases would be something like this. Standard overlap. That's the basics. I would set two objects. Set A with 3 numbers. Number 1, 2, and 3. That's going to be an object. And the other object is set B with 3 numbers, 3, 4, and 5. The expected result is 1, 2, 3, 4, and 5. This confirms that duplicates are handled correctly. On set is empty. That's another case to test. I would put 2 objects. Set A going to be 1, 2, and 3, and set B is going to be an empty object. The expected result is 1, 2, and 3. This ensures the function works correctly with an empty input. Identical set. That's another test. I would take I would set 2 objects. Set A, I would put the number 1, 2, and 3, and set B, I would put the number 1, 2, and 3 also. The expected result is 1, 2, and 3. This validates that the union of a set with itself is the set itself with no extra elements. This method provides a clear, efficient, and robust way to calculate the union of two sets. So this is my video. Thank you very much.